Let's talk about today's lesson. Well, today's math workshop. Starting it off with number 1. Make sure you put your name on your paper, please, so if it ends up in the floor, it goes back to you. All right, number 1. What is the best description, or what is the best name for the shape on number 1? Jakaria? So quadrilateral is a good name. A quadrilateral means it has 4 sides. So does this have 4 sides? Yeah, so it is a quadrilateral, but there's actually a better name. This is a special quadrilateral, so it has another name. Morgan? A rectangle. So a quadrilateral is correct, rectangle. And in fact, which one? There we go. All right, in fact, quadrilateral kind of sounds more fancy than rectangle, doesn't it? All right, but in reality, the word rectangle is more special than quadrilateral. Quadrilateral just means 4 sides. It can be any shape with 4 sides. A rectangle, though, has to have these 90-degree angles at each corner, which makes it a special type. So rectangle is what the most descriptive name is. All right, what about on number 2? What is the most descriptive name for number 2, Braden?
Square.
A square. Now, here's what's interesting about number 2. Number 2 is also a quadrilateral. Number 2 is also a rectangle, because a square is a special rectangle. I have 90-degree angles. The only difference is all of these sides are also the same. On a rectangle, the sides can be different lengths, top and bottom and side to side. But on a square, they have to be the same all the way around. Well, actually, a square is just a special rectangle. So a rectangle is not a square in any way, form, or fashion. You cannot say that. But you can say a square is a special rectangle. A square is a special quadrilateral. All right. Let's look at number 3. Does anyone know the name of number 3? Gabriella?
Quadrilateral.
It is a quadrilateral. It has 4 sides, but this also has a special name. Jakaria?
Well, wouldn't it also be an isosceles?
So you're thinking of triangles, all right? Because that means 2 sides are the same, which if I look here, the sides are the same, but this is not a triangle. So that's a good try, because there is something right about isosceles. It's just not the triangle shape. Peyton? It looks like a rectangle. The problem is it's slanted. Rectangles can't be slanted. Mason?
I might be wrong, but it's a pentagon.
It is not a pentagon. Means it has to have 5 sides, and we only have 4. Frank? Parallelogram. So I'm going to write parallel, and then we have O-gram. It literally, you spell it just like you say it. Parallelogram. All right, the reason this is a parallelogram, if I look at the top and the bottom, those lines that I just drew are going the same directions, aren't they? So those 2 lines are parallel. The 2 sides here are parallel. So a parallelogram is also a quadrilateral. It's also, that's it, it's just a parallelogram and a quadrilateral. But a square, so we've already said a square is a quadrilateral. It's also a rectangle, and it's also a type of parallelogram, because if you look, these sides, are they going the same direction? Top and bottom, are they going the same direction? A rectangle is a quadrilateral, and it's also a parallelogram because those lines are parallel. So, number 3 can't be a rectangle, can't be a square. It's more specific than a quadrilateral, so we name it parallelogram. Are we okay with 3? All right. Number 4. Number 4 is it looks like a diamond, but if I look, are those lines parallel? Yeah, so it's a parallelogram. Now the difference is, this is kind of like a rectangle. A special rectangle is a square. A special parallelogram also has a name. Do you know what that is, Easton? Rhombus. So R-H, it's a silent H, O-M-B-U-S. Rhombus. Are you writing this down? Carry on up. Whatever we're doing, I need it to stop, okay? All right. So it does look like it's the shape of a diamond. That would be, I've heard a lot of people today say diamond. The problem is diamond is not really a mathematical word. All right, so we would call that, the actual technical term is a rhombus. All right, number 5. Anyone know what number 5 is called? Number 5, Mason? That would have 6 sides. This has 4. Frank? Trapezoid. So we're going to have the word trap, T-R-A-P, E, zoid. Zoid. Trapezoid. We're also learning to sound out words today. Okay. All right. All right, and then this last one. What would this last one be called? It looks weird, right? Very well. It is not a trapezoid because a trapezoid has to have two sides that match. So these two sides are parallel. On a trapezoid, none of these are parallel. They're all going in different directions. Any other guesses? I'm going to come to you, Frank. Give everyone else a chance to guess before we go over there. Any other guesses? RJ? All right, so parallelogram, I mean all the sides are in the same direction. All of these sides are not in the same direction. So that one's not going to work. They're not parallel lines. Gabriella? Quadrilateral. This one has four sides, but is there anything special about those four sides? No, all four sides are real wonky looking. So this is just a quadrilateral. Quadrilateral. So quadrilateral. All right, are there questions about the first six? All right, I'm going to pass out our notes for today. I'm going to pause the recording and pass out our notes for today. All right, so looking at our notes today, we do have a test Friday. This vocabulary is on there. A lot of this vocabulary is review. The only thing that's not review is down at the bottom on number 6 where it has a star. Mary Webb, in front of you, please. All right, number 1 says we need to change mixed numbers into blank. It says when dividing. Now today we're going to learn to divide fractions. All right, but this rule also works when multiplying. This rule also works when multiplying. So what do you have to do to mix numbers? We've done multiplying. What rule do you have to do to mix numbers when you're multiplying? What do you have to do to mix numbers when you're multiplying? What do you have to change them to look like when you multiply? Peyton? Okay, so we need to make it just one fraction. Keegan, what's that called? If it's a mixed number, what's the other form of a fraction called? Mary Webb? Improper. So we have to change mixed numbers into improper fractions when dividing. Improper fractions when dividing. Okay. The next one says a whole number and a fraction create a blank. So if I put a whole number and a fraction together to make one number, what is that number called? Jeremy? A mixed number. Guys, this is exactly how it's going to be worded on the test. So please make sure this week you find some time to study these. You can fill in the blank without me up here telling you what should be there. All right, on 3 we have an example of a mixed number. What is the 5 called that's in that mixed number? Julia? It's called what? The whole number. The whole number. All right, what's the 2 called, RJ? The numerator. And what is the 3 called? Gabby? Denominator. All right. Blank is an expression that is written as a numerator over a denominator separated by a line. What did we just describe in that sentence? Jakaria? A fraction. It sounded like a fraction because it is a fraction. Right? And then number 5, the top number of a fraction that tells you how many pieces a fraction contains is what, Mason? The numerator. All right, and then number 6. So number 6 has a star. So this is a new word we're going to learn today. Blank is when you flip the fraction. So when we flip the fraction, the top becomes the bottom, and the bottom becomes the top. Peyton, you know what that's called? We have not talked about it yet this year. All right. This is called the reciprocal. Reciprocal. All right, what I think is interesting about a lot of words that we use in math, they come from words that are used in English every day. So guys, the word reciprocal is a noun because my fraction changes to a new thing, and a noun is a person, place, or thing. Okay, so the reciprocal is the fraction that's flipped over. In your regular English language, we would use reciprocal, we would use it as a verb, and that verb is reciprocate. Okay, so I'm going to give you an example of the word reciprocate in case you haven't ever heard it. At Christmas time, when someone gives you a present, you typically reciprocate. What does that mean happens? Jeremy?
You get a present and then you give them.
Yeah, so if someone gives you a present, then you would in turn give them a present. Typically, that's the way that goes, right? You exchange presents. So what's happened is, in the beginning, you were the receiver, yes? And then when you reciprocated, that person became the receiver, and you turned into the gifter. All right? So y'all swapped places when you reciprocated. Y'all agree with that? Okay, here's another example. Some of y'all can relate. Thank you. I couldn't think of that word. Some of y'all can relate to this. All right, let's say you leave math class, and you're walking down the hallway, and someone shoves you. Okay? So a lot of us would probably be pretty angry, all right? When that happens, when they shove you, you are the victim. You have been unjustly shoved. But typically what I've seen happen, especially, with 6th graders, we still lack a little bit of maturity. So when someone does something to us, we tend to reciprocate. So instead of just letting it go or letting a teacher know, we reciprocate the action and shove them back. Are we the victim any longer? No, now you have become the person that is in the wrong. So instead of letting it go, letting someone know that someone did something wrong and them being in trouble, now because you reciprocated that action, you are no longer the victim. Now you are also the one that is done wrong. So do you see how then you've changed places? So does it make sense that a reciprocal in math is where my top number and my bottom number just change places? I know that was a really long, reach around, all right, but a lot of times if we can make sense of it in the regular English language, in math it makes a little bit more sense. All right, so reciprocal, they're changing places. Y'all good with that? So let's actually write down what the reciprocal is. And you have to do this on the test Friday. All right, so we're going to have to say what the reciprocal is of 4 over 11. So if I have those two numbers change places, what new fraction will that make? Braden? 11 over 4. Now guys, you'll notice I did not put an equal sign there. Because is 4 over 11 the same thing as 11 over 4? No, they are not the same thing. They have changed places here. This is an entirely different fraction. So I'm not going to put an equal sign. Instead, what I'm going to put, guys, is I'm going to put an arrow. Because is that 11 over 4 still connected to it? Yeah, they still go together, but they're not equal to each other, so I don't want you to put an equal sign. Okay? They're complete opposites. All right, so we don't want to put an equal sign and say they're the same. All right, so let's look at number 2. So let's draw an arrow, because it's going to change. What is 8 over 12 going to change to? Mary Webb? 12 over 8. All right. Huh? You could simplify, but on the reciprocal, all we're doing is we're flipping them. So we like reciprocals. You don't have to do any extra math. Just flip it. Okay? Now I say that, but then we look at number 3. If I look at number 3, I can flip the 1 and the 2. They can change places. Is there anything for 4 to reciprocate? No. Is there a number for it to change places with? No. So, since there's not a number for 4 to change places with, we cannot find the reciprocal of this number. So what am I going to need to do? Because there is such thing as a reciprocal, but I need to fix it first. Zakaria, what do you think I need to do here? Jeremy? Make it improper. So I want to make it to where I only have a top and a bottom, because then can the top and bottom change places? Yeah, but I can't have this number in the front. So this is what we did last week. So we're going to take the 2 and we're going to multiply it. So 2 times 4 is? And then we're going to add our 1. So that gives me 9. So I get 9 over 2. This time I am going to put an equal sign. Alright? A mixed number and an improper fraction are the exact same thing. Just this way it's a mixed number, this way it's improper. Are those equal? They don't look the same, but they are the same number, okay? So this would have an equal sign. Now can I find the reciprocal of 9 over 2? Would I put an equal sign for the reciprocal? No. So I'm going to draw my arrow. So this is changing to a completely different number now. What is my new number going to be as the reciprocal? Carrie? When I change those places, what am I going to get? 2 over 9, 2 ninths. So all you're doing for the reciprocal is changing places. If it's a mixed number, that's okay. Make it improper, and then you can change their place. All right? Are there any questions about 1, 2, or 3? And reciprocal. All right? So we need to actually learn how to divide fractions. We need to learn how to divide fractions. All right, guys, I'm going to talk real quick before we start dividing fractions. My steps for multiplying fractions. So when I multiply fractions, what was step 1? Step 1, Jakaria? Make it improper. What was step 2? Simplify. And step 3? Multiply. Okay? So I want us to look real quick at these steps for dividing fractions. Step 1 still says change it to improper. So step 1 is the same, right? Step 2 has a star. That means it's important. This is what makes it division. Step 3 still says to simplify, so they match. And then the last step is still multiply, so they match. All right, so let's talk about this one right here. Do y'all see that big old, that star? That step is really important. It says keep, change, flip. What does the word keep mean? Peyton.
Just keep it for yourself.
Okay, keep it for yourself, no sharing at all. What else could the word keep mean? Mary Webb? Keep it the same. Keep it the same. Last period they said the word keep means to save it. So you save it just the way it is. You don't want to change it. Y'all agree? All right. Since this is the first word, this is talking about the first fraction. Okay, so underneath this I'm going to put first fraction. And I should have left some space, but I didn't really plan on writing that in there, and then I realized, oh, that makes sense. So we're going to keep our first fraction. We're going to leave it just the way it is. We're going to save it. We're not going to change anything about it. Then it says to change. So right after we keep something, then we're going to change something else. All right? So in a division problem, you would have a fraction. Then you would have a division sign. I want to change my division sign to a multiplication sign. So I'm going to change the problem to multiplication. Because raise your hand if you can multiply fractions. Should be everyone in here because we took a quiz on it. Okay, good. All right, so we're going to multiply. And then flip, what was that also called where we flip the fraction? What was that called? Reciprocal. So this is the reciprocal. All right, reciprocal. Yeah, we just talked about it.
No, like I feel like the meaning, but why they make it that.
Because the top and the bottom are changing places. So you're reciprocating.
Reciprocal is
Swapping places. right. So, keep, change, flip. We're going to shorten this to just KCF. You'll hear that in a lot of your math classes where they say KCF. Please do not get that confused with the chicken place. Yeah, it's not KFC. We're not getting some fried chicken. We're doing math. So it's KCF, okay? All right, after we KCF, then it's multiplication. I can simplify and multiply. Guys, here's the rule. You cannot simplify unless it says multiply. Get it? So you cannot simplify unless it's multiply. So if that problem doesn't say that you're multiplying, can you simplify? No, not until the very end. Okay? So let's look at this first problem. So number 1, do I have any improper fractions that need to change? Yeah, 5 1/3. Is that improper? So we need to change it. Y'all know what improper fractions are, right? We just talked about it. I'm sorry. I see what I said wrong. Do we have any mixed numbers that need to change? Yes, it would help if I said the right word, wouldn't it? Okay. So this mixed number needs to change to improper. And we're going to write a little small here, guys. I did not leave us with a whole lot of space. So we're going to do 3 times 5 is 15, plus 1 is 16, and underneath we're going to put a 3. Divided by. All right, does 4 over 21 need to change?
Yes.
We are only changing fractions that are improper. I've had a lot of people today that want to do step 1 and step 2 together. Please do not do that. If later on, if you feel like you are just the best at dividing, fine. But for this day 1, the first day that we're doing it, don't shorten your work. Give it all. Okay? So now we've made them all improper. So are we good? Okay, so now we're ready to keep, change, flip. So keep means the first fraction, right? So 16 over 3, what am I going to do to it? Keep it. So are we going to do anything? No, so it's just 16 over 3. Change. What am I changing? Peyton? Yeah, I want to make it say multiply. So I'm going to put a times, multiply. If you want to use the X, you can. So I'm going to do times. And what am I multiplying it by? What's going to happen to my second fraction? Is it going to stay the same? Are we going to change it? What is my second fraction going to say? Carrie?
316.
All right, the first fraction stayed like this. My second fraction is this 4 and 21. So what's it going to be? You were doing it right a minute ago, Julia. 21 over 4. So you did it right, Carrie. You just said the wrong fraction. You see what I'm saying? All right. So, guys, this is really, really important. Am I just flipping everything around? No. I'm only flipping this last fraction before I work it. Okay? So the reciprocal is important, but we just can't be reciprocal and all over the place. Okay? All right. So now I can multiply these across. I can do 16 times 21 and 3 times 4 and get these really big numbers and simplify it. Or I can try to simplify ahead of time. Once it says multiply, you can simplify. Okay? So what can I simplify in this problem right now? Kelsey? 4 and 16. What number can go into 4 and into 16? 4. So I'm going to do 16 divided by 4 is 4. And 4 divided by 4 is 1. Okay? I don't know why that's there. It's just times. All right. Anything else? Oh, y'all, I didn't. This should have been this 16 is 4. Sorry. Okay. Anything else we can simplify on this problem? Jakaria?
21 and 3.
21 and 3. What number can go into 21 and into 3?
7. Well,
3. So 3 divided by 3 is 1. And 21 divided by 3 is 7. All right, guys, this number, that should have never changed. That does not say to multiply, so we cannot simplify. I just marked the wrong one. All right, y'all see where we marked them? Good. All right, is there anything else that can simplify down here? No, so on the top, 4 times 7. Peyton? It's 28, and 1 times 1? 1. can I leave that as 28 over 1? No. So what am I going to change it to? 28 whole amount. Okay. Number 2. Number 2, do I have any mixed numbers that need to become improper? Any mixed numbers that need to be improper on number 2? RJ, what needs to change? Yeah, 2 and 7/10. So we're going to do our multiply and add. None right here. All right, so multiply and add. So 2 times 10 is, oh, well, let's go ahead. Am I going to change 3/8? No, so I'm just going to leave 3 over 8. We still have division because we're not ready to KCF yet. 2 times 10 is 20. 20 plus the 7 is 27 over. Okay, this is still dividing. Now we're ready to KCF. So K, what's my first fraction going to be, Keegan? Huh? What's my first fraction going to be? 3 over 8. Change. There's not Christian. There's a C. What am I going to change? What is it? What should the problem say next? Multiply. So we're going to put times. So we have 3/8. We changed. We got times. And then it says to flip. Frank, you're my only F. So what am I going to get when I flip it? 10 over 27. Okay. Hi.
Sorry to interrupt. So if we disconnect this one,
Can I finish recording?
Can you get back up and
Yes.
back again?
Yes, I can. Okay, so from here, guys, we need to simplify. What am I going to do to simplify? Braden, can you see anything on this problem that will simplify? Remember, we're looking at tops and bottoms. Anything on the top that will simplify with anything on the bottom. Julia, help me out. Thank you, guys. 10 and 8. What number can go into 10 and into 8? 2. So 8 divided by 2 is 4. And 10 divided by 2 is 5. Okay, what else can simplify on this problem? Jakaria. What number can go into 3 and into 27? 3. 3 divided by 3 is? 27 divided by 3 is? 9. Okay, anything else? Okay, on the top, 1 times 5. 5. And on the bottom, 4 times 9. 36. And that's going to be our answer. Okay? Alright, so I'm going to stop my recording. Alright, if you'll flip it over, guys, I want you to start. We're going to look at some together.